Thank you for attending the webinar today. We're going to talk about our hyper-converged appliance. We have three different architecture of hyper-converged appliance. One is called single node, which is basically a single controller with the RAID controllers and dual power supplies, hypervisor included, would have hard drives, SSDs, and fully virtualized environment. This could be the hypervisor, could be a VMware hypervisor, or could be Hyper-V. Either one the customer can choose. Dual power supply here, active redundant. The second architecture which we are focused today is going to be our HA unit or HA node, and the way it works, it starts with two head unit and then shared storage, and the shared storage has a dual active RAID controller in there, so it acts as an offload for processing all the activities for hard drive. We'll talk about it a little bit later on. And this is we call HA node. This is we call single node. Then we have a scale out, which is basically more of a single node, but in a cluster scale out format, and this can go for many nodes. So far, it's either 256 nodes or higher. Depends on your network and your requirement, so it can scale out pretty to a pretty big size. These scale out nodes are pretty much from the single nodes that if you have two nodes becomes replica, means that they would mirror each other. If you have three nodes, then it would the third node would be redundant. We use erasure coding in this, and the fourth node, again, you can have multiple node to be, as a fault-tolerant redundant unit, and the rest of them as a useful nodes. So today we're going to focus on HA nodes and describe how the HA node works and the features it has. HA node, as we talked about, it starts with two head nodes, those two compute nodes, and then shared storage node. There's two architecture as we discussed before, single and the scale out nodes, or we call it shared nothing. They don't share any kind of storage, and all of them, they have their own storage. This is a shared storage. The advantage of sometimes the shared storage is that you use less hard drives to accomplish the same thing. Here you lose at least one node or more due to redundancy, versus here is that capacity of the nodes here. Here you need less drives to accomplish pretty much the same thing. So there's a saving in a hard drives that you would use. It would come would become very interesting when you use flash storage, which is expensive storage, and saving on SSD will help you a lot. Anyway, so the RAID controller has a two active RAID controller. These are compute node, and this is a storage node. And storage node, you can put SSD drives, and you can put hard drives. So basically the hard drives are here, as you see here, and you can place SSDs. There is no limit of how many of SSDs or hard drives you can do. The chassis here, this storage chassis could be a 12 bay or a 16 bay or a 24 bay, and plus the JBOD, so you can actually expand this with JBODs and have more capacity. This would go over 1,000. I think it's like 1,441 hard drives that it will support for expansion, which is another 6 more chassis. So, and each of them, you can have as many as drives that the chassis will allow you, which is 12 or 16 or 24. We called the first one, we called it, RAID array, and the other one expansion array. So expansion, these are expansion, and this is a RAID array. So our RAID array is the first unit, and then the second one, which has a RAID controller in it. The two active controllers, which are the compute part of the unit, it starts from here, which has a hypervisor. Each of them have a hypervisor in them. So this is the, I would say it's this area would be one of the RAID, the head unit, the compute unit, and this is another compute unit over here. And then this is the two RAID controller, and the rest are this chassis, which is basically RAID arrays. So the RAID arrays are the two RAID controller here, and then hard drives or SSDs, and then head controllers are basically the full controller plus it has a hypervisor embedded in it and storage controller. So a storage controller and the hypervisor are here. Storage controller and hypervisor are here. The storage controllers are clustered, and the hypervisors are basically the VMware or Hyper-V. They would be in a cluster as well. You can, in this configuration, if any of these head nodes fails, since it's in a cluster, it would fail over. And so either of the head nodes can fail, and then it fell over the active the storage controller also can fail, and one can fail. It would fail over to the second one. You have dual power supplies here, which protects this one. So the RAIDs, the drives are protected by these dual controllers and SSDs, and we'll talk about it a little bit more how the SSD is going to help you out. The dual head unit, they manage all the protocol connections between the units, at the same time, provisioning some of the storage outside as iSCSI or NAS. So you can actually provision some of these storage right here through these two controllers to other systems that you might have externally, and use this as a storage, iSCSI or NAS storage, or object storage on S3. The data services are executed on the head controllers, the compute. So it takes all the workload is handled like a snapshot, replication, and dedupe and encryption. For example, they're hardware-based enabled dedupe and encryption, so it's handled by hardware. So they're very high performance. So the data services are snapshot, encryption, dedupe, replication, synchronous, asynchronous replication, tiering, caching, Cloud Connect, and so on and so forth. And the connection between the storage controller, then head unit, there are two type of connection you can ask when you order the system. Could be a SAS 12 gig for 4 lane, which gives you 48 gigabit per second, or could be a fiber channel 16 or 32 gig fiber channel based system. Most of people use the SAS because SAS 4 lane is 48 gigabit, very fast interconnect, between the compute and storage here. You can increase both nodes. You can actually scale out within the unit. This is one node only, but this one node is very redundant HA node, so we call it HA node, right? And you can have multiple of these nodes in a scale out. So this could be actually an HA node, and this could be a HA node, and this could be a HA node, or it could be mixed, some HA and some non-HA. At the same time, the HA node is a fully self-contained hyper-converged appliance by itself. If you decide you want just to extend or scale only the head unit or compute, you just get the compute unit and that's it. Then you just put more compute unit and that's it. You use those compute units. If you are going to get compute unit and storage, then you get the node, scale out with compute, which has a storage in it as well. So you can go both way for expanding this unit and, just making it more, or you just can, put the full HA unit. So you have a lot of flexibility. So the flexibility of expansion of this unit is either put more head units here, and so you can go this direction, or you can just put more array unit, and more array unit, and then JBODs and JBODs and JBODs. So this supports that area. Usually Fiber Channel, there is no limit of how many RAID arrays you can have. On the SAS, you're limited to number of controllers we can put in there, usually 2 or 3. All the workloads are running in these 2 head nodes or more nodes that you might have as a compute. Those virtual machines runs on this. And the more CPU and memory you have, you can run more workloads. And then, if you need more, connections, network connections, and so on and so forth, redundancy and everything else, you can kind of design the system to be anywhere you want. It's a Lego architecture, so we call it modular. So it means that you can rearrange this as you want. It's pretty much a very much software-defined storage. The 2 storage controller that it's within these units are virtualized. And integrated into the hypervisor itself. So it manages provisions 3 types of storage to the hypervisor. The iSCSI as a block mode for your high performance workload. NAS for sharing. So sharing or shared storage type of thing, repositories, NFS and CIF support, and then object storage S3 connection to Amazon or to Azure. And you can use those as a local storage, means you can get cloud storage and provision as a local storage, like a local storage. We call it storage pool. And then be able to use that as a local storage. And of course, you can provision some of the S3 as a local storage if you need, like archiving or some object storage that you need to use this for. As I said, all the storage within this unit also can be provisioned as a target storage to outside hosts that you might have. And the network cards that you can put in this is, comes with the standard 10 gig, 1 gig, 10 gig auto configured and auto connect. Usually comes with every head unit comes with the 2 as a standard. You can increase that to 4 or 8 per head unit. So it's very easy upgrade for you. You can also upgrade memory in each head unit, compute unit, from 32, 64, 128, 256, 512, and up to about 1.5 terabyte on each head unit. And you can have more than 2 head unit, 3 head unit, 4 head unit, and 5 head unit, or compute node that you want to call it. Just and on a storage part, as I said, you can have a mixed environment. We use 12 gig SAS hard drives, enterprise hard drives. These are 4 lanes, so 48 gigabit, and then we also use the 12 gig SAS flash storage on these SSDs, and those could be anywhere from 480 to 7 terabyte unit, and then those are used for mostly for high performance applications when you have flash. And the flash, you can use it for a number of things. One, you can use it as a cache, so it sits in front of your storage pool as a cache, or it can be as a tier. Tier, the difference between cache and tier is that cache, every if it's sitting in front of a storage pool, everything going to this storage pool comes to this cache first before it goes out. And if it's available, means it's mostly used recently, then it's always in the cache when you do the read. So this speeds up your operations, IOs. And if you are going to use this as a tiering, that's a policy based. You mostly set up the policy as most used, or recently. So the date or more frequency of the usage, you say keep it here. The least used within the time frame, whatever, or the least used, or that this time frame moves to the lower tier. This lower tier could be magnetic disk or could be cloud. It can just move it to the cloud as well. Or you can use the SSDs as a directly storage, so as a storage directly, and you can write to it as a target storage. And as I said, fiber channel storage, and not fiber channel, the iSCSI storage, NAS storage, and object storage. So these are some of the SSD can be used. Mostly people use it for iSCSI, and then for high performance application that you might, because it's a block mode. So this is our the HA unit that we talked about. In the next session, we'll be talking about the single node and scale out node. And the single node is, as it says, is just a single node with dual power supply and one single controller, and dual sockets and memories and CPUs, and also it supports SSDs, and it's more affordable because it has less components. It's a single controller, and the scale-out controller in each of them, it is like a single controller, but many nodes, and 2 nodes or 3 nodes or 4 nodes and all that. So it depends what your requirement is. Thank you for attending this webinar. I appreciate your time. If you have any question, please let us know at sales@stonefly.com. Thank you.